All right, lesson 1-3, part 2. This one's going to be much shorter than the last lesson was. And in this lesson, we're going to continue our discussion with square roots and talk about rationalizing the denominator. So our objective today is what rationalizing the denominator is. We want to rewrite square root expressions to remove radicals from the denominator. So when I'm looking at this expression here, let's look at this one first. We know that the square root of 49 over 81 is the same thing as the square root of 49 over the square root of 81. And we know that the square root of 49 is perfect, 49 is perfect square, so the square root of 49 is 7. 81 is a perfect square, the square root is 9. So we have simplified it, and in simplifying it, we removed all of the radicals from the denominator. That's nice. But in this problem, 2 root 2 over root 3, there's no amount of simplification that will get rid of the square root in the denominator. I could try to rewrite it as 2 times root 2 thirds, but I still can't do 2 divided by 3 and get a nice whole number. It's going to give me a crazy decimal, and I can't split this up or break it up or put it together in any way that's going to get rid of this radical 3 in the bottom. Not with any method that we have right now. So I don't want to do that. I'll tell you what, let's take this guy, let's put him on his own slide, and let's talk about it a little bit more. And when we're talking about rationalizing the denominator, let's go grab this guy too. We're talking about rationalizing the denominator. What we're really trying to do is put a rational number in the denominator. We don't want irrational numbers in our denominator. And if you think back to when we talked about properties of numbers, any non-perfect square root is irrational. So the square root of 4 is a perfect square. 4 is a perfect square, so the square root is 2. But the square root of 3 is not. It's going to be an irrational number. Decimal goes on forever. It never stops. It never repeats. So we want to get rid of that in the denominator. We always want to keep our radicals up top. How can we get rid of a square root? Well, we have to ask ourselves, how do you make a square root go away? What could I do to the square root of 3 to take that square root symbol away? Could I add something to it? No. Could I subtract something from it? Nope. What about could I multiply the square root of 3 times something to get a number that is not a radical? Sure. What if I multiply the square root of 3 times the square root of 3? Well, anytime I multiply a square root by the same exact thing, it almost like cancels it out. It undoes itself, right? I could write this out long ways, and I would get the square root of 3 times the square root of 3 is the square root of 9, using the product property we talked about. And the square root of 9 is just 3. So if I look at 3, the square root of 3 times the square root of 3 is 3. Well, the square root of 5 times the square root of 5 is 5. And the square root of 4 times the square root of 4 is 4. We can see it with nice perfect squares a little clearer. 2 times 2 is really 4. So how does this help me when I'm trying to get rid of this square root down here? Obviously I changed the value here because 3 doesn't equal the root 3, but we were just talking about what could I possibly do to root 3 to get rid of that radical. Well, we already said that we could multiply it by root 3. But if I don't want to change the value, what do I need to do to the numerator? I need to do the same thing. Multiply it by root 3. Now, what am I really multiplying this entire equation by? Or this entire expression, rather, by? This entire expression is being multiplied by root 3 over root 3, which is just 1. I'm not changing the value at all. I'm just writing it a little bit different. Root 3 divided by root 3 is 1. So how do I write it a little bit different? Well, the reason I choose root 3 divided by root 3 instead of root 5 over root 5 is I'm trying to get rid of this radical down here. When I do that, I multiply fractions, top times top, bottom times bottom, right? So on top I get 2 root 2 times root 3, and on the bottom I get root 3 times root 3. Now the product property of radicals, I can combine these two together and I get 2 root 6. And on the bottom, root 3 times root 3 is just 3. So my rationalized form is 2 root 6 over 3. No more radicals in the denominator. I changed the way it looks a little bit, but again, if you take your calculator and you punch in 2 times root 2 divided by root 3, you're going to get the same value as 2 times root 6 divided by 3. It'll come out the same exact value. In fact, I'll do it for you really quick. 2 times root 2 divided by root 3 is 1.6329, and 2 times root 6 divided by 3 is also 1.6329. On and on forever. I abbreviated the decimal. It's going to be an irrational number. So rationalizing the denominator, we just need to multiply it by the radical that's in the denominator. Let's give this a shot with a couple of numbers, huh? What would I do here? 5 over root 10. Well, I need to multiply it by something to get rid of this root 10 in the bottom. How do I get rid of root 10? I multiply it by itself, root 10. If I do it to the bottom, I have to do it to the top because I don't want to change the value. Top times top, 5 root 10. Bottom times bottom, root 10 times root 10 is just 10. Am I done? Is there any more simplifying to do here? Hopefully you're saying yes, because now I've got to worry about 5 over 10. I can reduce 5 and 10. The 5 can become a 1, the 10 becomes a 2. So I end up with root 10 over 2. Don't fall into the trap here, folks, and tell me that this answer is the square root of 5. We cannot go any further here because I have a radical on top and a whole number on bottom. I can't jump in and inside and outside of the radicals. This is as simple as it gets right here, folks. The square root of 10 over 2. It does not equal the square root of 5. We're just going to X that out really big like, because this is in a radical, this is outside of a radical. We can't do a division between those two things. All right, let's look at this next problem here. 3 root 5 over root 7. Hopefully you're getting the concept. We're going to multiply it by root 7 on the bottom to get rid of the radical. If I do that, I got to multiply the top by root 7. So 3 times, top times top again, 3 times root 5 times root 7 over root 7 times root 7 is 7. I need to simplify the top one more time. 3 times root 35 over 7. Now, can the 3 and the 7 reduce? No, they cannot. I need to double check and see if there are any perfect square factors inside of root 35. And it turns out that if I look at my perfect square factors, I've got 4, skipped one, 9, 16, 25, 36. Well, 35 can't be divided by 25 and get a whole number. 16 doesn't go into it and get as a whole factor. 9 is not a whole factor, and 4 is not. So this is as simple as we get right here. Now, let's be careful, and you're not going to get the wrong answer if you approach this problem. You guys are probably on the process train right now. You're doing exactly what I did, and you're saying, well, this one's easy. I just multiply the bottom by root 18, and I multiply the top by root 18. You'll get the right answer. We'll get 8 times 18, what is that? 80 and 64, that's root 144 over 18. And we know that 18 on the bottom, we've already gotten rid of our radical, so we're halfway there. And on top, the square root of 44 is 12. So we get 12 over 18. Now, what we need to do is simplify our fraction. I can reduce both by 3. And I can get 4 over 6. I can reduce those both by 2 again, and I get 2 over 3. Obviously, I could have done this by 6, but even if you see one portion, you can reduce it a little bit and then see if you can reduce it again, just like with our square roots. So if you saw that you could take a 6 out of both here, you could have just jumped to 2/3. Yeah, I took an extra step. I took out a 3, and then I took out a 2 after that. I'll get the same answer. Now another way to do this is to rewrite this problem to start with. We'll make our problems a little bit easier if we do this. And it doesn't matter to me how you do it, but the approach may be a little bit simpler. If we took this problem, we rewrote it first. I'll use green. Rewrote it as the square root of 8 over 18. Now, we can simplify this. We can break it down, divide both by 2 right now, and we get the square root of 4 over 9. Now, when I break this down, my quotient property of square roots allows me to go the square root of 4 over the square root of 9, which is also 2/3. There are going to be many ways to get to the right answer when we're dealing with simplifying radicals, and you have to come up with the way that you want to do it, the way that you feel is best. The only way you're going to get there is by doing practice. So in class, we'll have lots of problems to practice through, and right now you have a concept check to work through. Either of these processes is correct. It leads to the right answer, but I would say that one way, the green way, is a little bit simpler, offers less room for error than doing it the more complicated way up here. So give your concept check a shot and let me know if you have any questions. We'll see you in class.